Photonics is the control and manipulation of light, in the same way that electronics is the control and manipulation of electricity or electrons. And the idea is, how can we use different material properties and different configurations of geometry in order to manipulate that light to do something useful?
Quantum technologies are essentially technologies that harness the quantum nature of light and uniquely quantum effects. For example, superposition, where you can have quantum state that is in two possibilities at the same time, or entanglement, where you can have quantum effects shared across a large distance.
Over the past decades, our technology has become so good, and this opens quite a lot of opportunities, because if you can control, for example, single atoms or single electrons, then you can have amazing spatial resolution in sensing. Even beyond that, you can have access to some phenomena and effects which are only prescribed by quantum mechanics. These effects can give you some advantages in sensitivity and in, for example, computational powers. And this goes beyond anything you can really do with classical physics.
The research that I'm doing is still quite fundamental, but it is oriented towards the realization in the future of a so-called quantum network, the quantum internet. The idea behind the quantum internet is to use quantum mechanics to deploy a communication network that is faster, but it's also more secure than what we currently have.
If you want to transmit quantum-enabled light over long distances, you need to use photonic technologies like hollow core optical fibers, which maybe preserve the properties of light in order to do that. So there's a lot of strong interaction between the photonics and quantum teams here at the university.
Everybody here likes working with each other. It's extremely friendly. It's very, very conducive to collaboration. And then we have ideas that are really complementary.
So we're always interested in understanding how the work can impact outside of the university. There are companies that we work with extensively that produce new products or new processes or manage to contribute to society in a wider role. We're seeing a lot more emphasis these days with the idea of net zero and transitioning to a low carbon economy. And a lot of that actually requires manufacturing new products that do the equivalent job. So actually seeing some of our research being translated into those areas is really quite exciting and impactful. And that's really what we want to see going forwards.
If we want to make more accurate measurements of the climate in order to establish how the climate is changing, how quickly it is changing, whether humans have a role to play in it, we can do this through developing better technologies, and quantum mechanics enables us to do that with a better sensitivity, or possibly cheaper than we could do it before.
Excitement really comes in where we can see the applications coming through and providing real benefit to the end users. The technological improvements that people have seen over the last 20-25 years, a lot of it has actually been driven by photonic technology. It's behind the scenes, if you like. It's the engine that's powering the technical revolution.